Alright, this is Unit 5, Lesson 1, Graphing Linear Equations using a Table of Values and using X and Y intercepts. The solution of an equation is the set of all points, those are ordered pairs with an x, y, that make the equation a true statement. The graph of an equation is basically all those solution points plotted on a coordinate plane. So here we are, in example 1, we're given an equation and we want to know if these ordered pairs are solutions. So what we need to do is plug in the values to see if it makes a true statement. So a value of x is -2 and our value of y is 5. So I'm going to go ahead and plug in -2 for x, 5 for y. Here's y plus -2 equals 8. So the question is, does that come out to equal 8? So I'm going to simplify this side. I'm going to get 10 minus 2. Does that equal 8? 8 equals 8. Yes, it does. So that means that, yes, that is a solution. Try the next one. 2 times y value of -4 plus x value of 0 equals 8. We get -8 equals 8. That is not true, so no, it is not a solution. Alright. Now we're given a bunch of different equations, and we need to know which one represents this graph. So I take a look at the graph and I think to myself, hey, look, I can see some ordered pairs on there. There's a bunch right here. This one is the ordered pair 2, 0. This one up here is the ordered pair 4, 6. This one down here is the ordered pair 1, -3. So I know that if I plug any of those ordered pairs into my equations, it's got to make a true statement. If it does, then we know that it's the solution. It's that graph matches the equation. So I'm going to start off with the first one, and let's just take the ordered pair 2, 0. So I'm going to test it in this one here. So I'm going to do 3 times 2 plus 0 equals 6. Is that true? 6 equals 6? Yes. All right. So we would think, hey, that's the solution. However, that's just one little point. And we know that there could be a whole bunch of other lines that go through that same point. Right? I could have a line going this way that goes to that point. That would be a solution as well. So just testing one point is not enough. So I've got to test another point to confirm that 2 points are on that line, and then we know we've got a solution. So I'm going to try the 4, 6 point. So I'm going to say 3 times 4 plus 6 equals 6. I can tell already that is not going to work out. That is not true, so we know that's out. Let's try the next one. Let's try 2, 0 again. 2 plus 3 times 0 equals 6. I get 2 equals 6. That one's out. Alright, let's try the next one. I'm going to try 2, 0 again. 3 times 2 minus 0 equals 6. 6 equals 6. Alright, that's looking promising. One of those points works. Let's try another one as well. Let's try the point 4, 6. 3 times 4 minus 6 equals 6. I get 12 minus, my pen is not cooperating, equals 6. 6 equals 6. That works as well. So we know that these 2 points are both on this line. And so we know that has to be the equation of that line. Alright, to graph a linear equation, we have a number of steps, and we're going to do them together with our first example, but I'll briefly go over them here. The first thing you should do is rewrite it into function form. Solve it, meaning solve it for y. Get y by itself and everything else on the other side. This is not absolutely necessary, but it just makes your life much, much easier. Then what we want to do is choose a few values for x. That's our independent variable. So we're going to choose a few x values and make a table of values. Then what we're going to do is plug in those points to find out the corresponding y values, the corresponding dependent variable. And so when we complete our table of values, we'll have y values in there as well. Then we're going to plot those points, and then we're going to use a ruler to connect the points to make a straight line, and then we're going to put arrows at the end to show that these aren't the only solutions, but that in fact it goes on infinitely. So let's do it together. Here's our first equation. The first thing we're going to do is rewrite this in function form. Standard form, we're going to subtract 2 from each side to get y by itself, and we get y equals 3x minus 2. That's just making our life a little bit easier. Now, our independent variable x, we can choose whatever we want. However, let's not pick 200 as an x value because that's way off of my graph. So I tend to pick points that are around the origin so that they will show up. I generally pick a negative and a 0 and then a couple positives. So negative 1, 0, 1, and 2 as my x values. We just get to choose any. That's what I've come up with. So now I'm going to plug those in for x and see what the corresponding y values are. So I get y equals 3 times negative 1 minus 2. And for that, you don't have to show me every single step. If you want to jump right to the fact that that is going to be negative 5, that's fine, and plug in a negative 5 right there. We're going to try another one. Y equals 3 times 0 minus 2. So for that, 3 times 0 minus 2 ends up being negative 2, so I put that in my tabular values as well. Y equals 3 times 1 minus 2. So in that case, y is 1. And y equals 3 times 2 minus 2, y is going to be 4. So what we've just done is create a whole bunch of ordered pairs that are solutions to this equation. So I'm going to plot them now. Negative 1, 2, 3, 4, 5 goes right there. 0, negative 2, 1, 1, and 2, 4. So you can see they all line up in a straight line. How convenient. That's exactly what we expect because we are giving you linear equations, which means all the solutions line up in a line. So we haven't included every single solution to this line. What if x was 3? There'd be another solution. What if x was 1/2? There'd be another solution. What if x was negative 278? There would be another solution. So what we need to show is that all the other solutions on here are all the points that are in between these and extending in either direction. Oh, I'm trying to use a ruler and it's not working. So I'm going to have to connect these without a ruler because if I put one on my tablet, it forwards. So you need to make sure that you connect yours with a ruler so they're nice and straight. And then we're putting arrows on the end to show that it keeps going and there are more solutions off the page. Whoops. All right, next one. Let's give this one a try. X plus 3y equals 6. First going to solve for y. I'm going to subtract 6 from each side. We get 3y equals negative x plus 6. Divide all terms by 3, and we get y equals negative 1/3 x plus 2. Now, when I go to choose my x values, I'm going to realize ahead of time that I need to multiply whatever I have for x by negative 1/3. So I'm going to choose my values wisely, and I'm going to choose values that make that into a whole number. So if I choose multiples of 3, life will be much simpler, and I won't have any fractional results. Fraction results aren't bad, but they're just easier to deal with otherwise. So when I go ahead, I'm going to just do the first one for you. Y equals negative 1/3 times negative 3 plus 2. When we do that multiplication, we ended up getting 1 plus 2, so y equals 3. All right, I'm going to go ahead and fill in the rest of the values here. And then when we go to plot them, I'm going to plot those points. Negative 3, negative 3, 3 is up here. 0, 2, 3, 1, and 6, 0. Nicely line up in a line. I'm going to connect them, make my line nice and long. I'm going to use a ruler when I'm not using my tablet, and put arrows at the end. All right, let's talk about X and Y intercepts. The X-intercept is the point where the graph crosses the x-axis. We know that. The Y-intercept is the point where the graph crosses the y-axis. Know that too. So, if you recall, to find the X-intercept, that's something we did when we were doing the zeros of the function. We set y equal to 0. Because we knew that all the points on the y-axis, on the x-axis, have an x value of something and a y value of 0. To find the y-intercept algebraically, we're going to set the x value equal to 0 because we know that all the points on the y-axis have an x value of 0 and some value for y. that's going to make life easier. Oops. When you name your X and Y intercepts, don't forget to write them as ordered pairs, since they are points on the line. All right. Using X and Y intercepts is a really handy way to graph, and it's quicker and easier in a lot of ways than using a table of values, because we only need to find 2 points, those special points, the intercepts. So I'm going to start off saying, hey, let's find the X and the Y intercept of this equation. So to find the X-intercept, it's going to be some number and the 0 in the place of Y. And so I'm going to go to my equation, and I'm going to put in place of Y a 0. So I get 3x equals 24. Divide each side by 3. I get x equals 8. So that means the x-intercept is the point 8, 0. Let's go ahead and graph it. 2, 3, 4, 5, 6, 7, 8. Right there. 8, 0. That's one of the points on the line already. All right, let's do another one. Now we need to find the y-intercept. So we know that our y-intercept is going to have some number for y, and the x is going to be 0. So now I'm going to plug in 0 for x. And I get 4y equals 24, y equals 6. So you'll find that some of these are simple enough, 0, 6, that you can get to the intercepts just by figuring it out mentally, looking at the equation in your head. So 0, 6, 1, 2, 3, 4, 5, 6. There we go. We've got 2 points. That's enough to form our line. I'm going to connect them with a nice straight line using a ruler. And put arrows at the end. Make sure that line is nice and long as well. All right, let's try another one. Let's find the X and Y intercepts and then graph them and to plot our line. To find the X-intercept, plug in 0 for Y. 5x equals 30. X equals 6. Therefore, the X-intercept is 6, 0. The y-intercept, plug in 0 for x. We get 0 equals 6y plus 30. We're going to subtract 30 from each side. Negative 30 equals 6y. Divide each side by 6. We get negative 5. You can see that I've stopped writing absolutely every step. I didn't write the divide by 6, divide by 6. At this point in the course, that's okay as long as you can do it correctly. So then we have 0, negative 5. Is my y-intercept. So let's go ahead and plot those. 6, 0 is right here. 0, negative 5 is down here. Don't forget to make a nice long line that goes all the way across your graph. Use a ruler, draw arrows.